Hi students, this is AJ sir. Let's study 10th standard ICSE math, exercise 17A part 2, circles basics. Hello students, welcome to another episode of fun as we solve circles 17A part 2. Let's start with question 34. Here one angle is given as 55 degrees and we have to find the values of x and y. X would obviously be double of 55 because it is the central angle, and central angle is always double of the angle at the circumference. So AOC is twice ABC. Notice that both the angles end with AC. Hence the property applies. So this is 110. How to find Y? Well, one method is you can just draw one angle like this. Or even if you don't, if you look at ABCD, that's a cyclic quadrilateral, isn't it? Now in a cyclic quadrilateral, the opposite angles are always supplementary. That means 55 plus y is equal to 180. So y is 180 minus 55, which is 125 degrees. That's it. There are many other methods you can use. For example, you can first find this reflex angle and then half of that is y. But let's stick to this easy method. These are the steps. Notice that everywhere I write the reason because it's necessary. Next, cancel the 35th sum. Let's solve sum number 37. Here, AB is a diameter. It is passing through the center. The moment this is mentioned, you know that this angle is 90 degrees, angle AEB, because it's an angle in a semicircle or an angle subtended by a diameter on the circle. Also, they have mentioned angle EAB. This is 63. Let me write it. Calculate EBA. Well, angle sum property. This plus this is 180. So this comes out to be 27. Next, calculate angle BCD, that is this one. Now, how do we do that? Well, they have mentioned that ED is parallel to AB. So that has to be useful somehow. I can see that DEBA form a Z. That means this angle is equal to this angle, alternate angles. DE parallel to AB. So if this is 27, the opposite angle of that is angle C in the cyclic quadrilateral EBCD. It's a cyclic quadrilateral. So if this is 27, this will be 180 minus 27, which is 153 degrees. Here are the steps. Next, question 39. Now here, we'll have to draw a huge diagram. I is the in-center. Make sure that for every sum you draw a diagram. It's compulsory in geometry. I is the in-center. In-center means the point of intersection of the angle bisectors. So BD is an angle bisector of angle ABC. That means this angle is equal to this angle. Similarly, if I join AI, that's an angle bisector. If I join IC, that's an angle bisector. Now BAC has been given as 55. That means this is 22.5 and this is 22.5. ACB is 65. ACB is 65. That means this is 32.5 and this is 32.5. Calculate DCA. So let me join this first. I want this angle. Can you tell me any angle which is equal to DCA? An angle which is in the same segment as DCA. An angle which also ends with DA. Well, DCA is equal to DBA. DCA and DBA are cutting the same arc AD. So they are angles in the same segment. So if I can find angle ABD, then that is also equal to angle ACD. But how can I find angle ABD? Well, that's half of this big angle. But then how do I get the big angle? Well, in this triangle, I know that angle A is entirely 55, angle C is entirely 65. So by angle sum property, I can find angle B, which is entirely 60 degrees. And half of 60 is 30. So this is 30 and even this is 30. If this is 30, then even this angle is 30 because angles in the same segment. So that's how we get Roman number 1. Write the statements exactly the way I have written. And don't just copy it, understand each step. Second one, angle DAC. This angle. Is there any angle which is equal to angle DAC? You should be able to visualize this. This chapter is all about being able to visualize which angles are equal to which one. DAC is equal to DBC, this one, because DBC is also cutting the same arc DC and DAC is also cutting the same arc DC. So they are angles in the same segment. And we have already proved that DBC is 30. That means DAC will also be 30 degrees. That's Roman number 2. Roman number 3, angle DCI. DCI. Well, it's a combination of these two angles. We know that this angle is 30 degrees. Now just get this angle and add them up. How do I get this angle? Well, it's half of 65 clearly because CI is the angle bisector. I is the in-center, that's why. So this is 32.5. So 30 plus 32.5 entirely is 62.5 degrees. So that's Roman number 2 and 3 solved. And now Roman number 4, angle AIC. That is the central angle AIC. It's going to be double of angle ABC. Angle ABC was 60, so angle AIC will be 120. There is another way to solve this. If you use angle sum property in triangle AIC, I know this angle, I know this angle, so angle sum property can give you this angle. So there are multiple methods. You should try solving on your own rather than just copying from here. Next, 40th sum is cancelled, not because it is out of syllabus, but because it is very huge and so vast that it cannot come in exams. 41st sum. Here the ratios are given and you have to find the values of x, y and z. So first of all, whenever ratios are given, we assume it to be k is equal to k, because when we do that, then we can assume x is equal to 3k, cross multiplying, y is equal to 4k and z is equal to 5k. So we have converted x, y, z, all three variables into a single variable k. If only we can find the value of k, then we can substitute it here and find the values of x, y and z. To find the value of k, we need an equation. We need to come up with some relationship between x, y and z. So looking at the diagram, what you notice is that this is a vertically opposite angle. Angle BCP is vertically opposite to QCD. So if this is x, this is also x. Now focus on triangle BPC. Here, angle ABC is the exterior angle for the triangle, and an exterior angle is always equal to the sum of the remote interior angles. So this becomes x plus y. Similarly, for triangle CDQ, angle CDA is the exterior angle, and exterior angle is always equal to the sum of the remote interior angle. So this becomes x plus z. Now these two angles, angle B plus angle D, should be equal to 180 degrees supplementary because they are opposite angles of a cyclic quadrilateral. That means x plus y plus x plus z is equal to 180. That's the equation we wanted, because now we can substitute the values of x, y and z in terms of k, solve the equation to get the value of k, Substitute and get the values of x, y and z. Next, let's do the 44th question. Here, 2 angles are given and 3 angles have been asked. Also, they have mentioned that AC is a diameter. That might come out to be handy. One more thing, DC is parallel to EB. So I guess alternate angles will come into the picture here. First of all, they want angle BEC. BEC. Well, can you visualize something? Isn't angle BEC half of angle BOC, which is the central angle? But how do I get BOC? Well, that's a linear pair with AOB. So if this is 80, this is 100. And if this is 100, this is half of 100, which is 50. So that's how we get this as 100, and this as 50. Notice how huge diagrams should be drawn so that it's easy for us to visualize the angles and write all the new values we are finding, which will be useful in Roman number 2 and Roman number 3. If you have a small diagram, it becomes very congested and you may not be able to understand how to solve. In fact, when the time comes for you to revise all the sums, I have an idea. You should photocopy the textual pages. It should be very clean, all these markings should be erased, and you should enlarge it. Make it twice the size or thrice the size. And then in the diagram, with your pencil, you should be able to solve orally each and every sum. So this way, quickly you can revise all the sums. And as far as writing statements is concerned, I'm sure that you would have mastered that art by the time you give your board exams. Like Roman number 1, these were the steps. Did you figure it out on your own, how to write the steps? Now figure out how to do Roman number 2. Angle BCD. BCD, that's the entire angle they want. That is this angle plus this angle plus this angle. Out of which this angle is 10 degrees, that's done. How do I find this angle now? Well, this angle will be half of this angle. That is angle ACB is half of AOB. Central angle is always double of the circumference angle. And both the angles end with AB. So this is 40 degrees. Next, if this is 50, then by alternate angles, this is also 50. Because DC is parallel to EB. So now I can just add them up and it comes out to be 100 degrees. This way. Next, Roman number 3, angle CED has been asked. CED, that is this angle. How do I find this one? Well, in cyclic quadrilateral EBCD, entire angle E plus entire angle C will be 180 degrees, out of which I know C is 100, so this is entirely 80, but this small angle is 50, so how much is this left? 30 degrees. How to write the statements? Like this. Next, question 45. Here again, this is a diameter, and we have to find ABC, that is this angle, plus CDE, that is this angle. So we need a construction out here. You should join BE. So draw the diagram in your tuition book. The moment we do this, we know that angle ABE is 90 degrees because it's an angle in the circumcircle, and A is the diameter, right? Also, BEDC is a cyclic quadrilateral. So angle EBC plus angle CDE is 180 degrees. Opposite angles of a cyclic quadrilateral are supplementary. So adding the two equations, I'm getting this plus this is totally 90 plus 180. That's 270. But this plus this is entirely angle ABC. So in the end, I get angle ABC plus angle CDE is equal to 270 degrees. Next, let's solve the 48th sum. Here, there are no values given. Only x is given, so all answers will be in terms of x. This is x. How much is COB? Now, if this was a complete circle, then you would have given me the answer instantly, because you could see that COB is a central angle and CAB is a corresponding angle at the circumference. So how much will COB be? 2x. That's right. Next, they want angle DOC. Now once you write 2x over here, DOC, this one, well, since AO is parallel to DC and this is x, I know that this will also be x, alternate angles. And if this is x, then this angle will be 2x, because if DCA is x, then DOA will be double than that, because it's a central angle for this angle at the circumference. So it's 2x. Now if this is 2x and this is 2x, and these three angles together form angles on a straight line, which is always equal to 180 degrees totally. So this will become 180 minus 4x. So that's the answer. Now Roman number 3, DAC. That is this angle. How much is that? Can you visualize it? Think. Well, DAC is half of DOC. DOC is the central angle and DAC is the angle at the circumference. So if this is 180 minus 4x divided by 2 will give me 90 minus 2x. That's the answer. And finally, angle ADC, that is this entire angle. Now what do you think? Well, there are a few ways to go about it. Can I say angle AOCD is a cyclic quadrilateral? No, it isn't, because point O is not on the circumference. So don't even think about that. How about angle sum property in triangle ADC? That'll work, because this plus this plus this is 180 degrees. Another option. How about this entire angle plus this entire angle is 180 degrees, because they are forming a C. So they are co-interior or allied angles between two parallel lines, and so their sum should be 180. So by that logic, this will be 180 minus the sum of this. And this will be the answer, 90 plus x degrees. So now look at all the steps. See how I have written the same reason. I've repeated the same reason every time. You can't do shortcut with reasons, because they carry marks. Next, let's go for 50th question. 49th is very easy, so I'm cancelling it to reduce your homework. In the 50th sum, this is 42 and we have to find this one. Now, there are a few ways to solve this. One way is, if this is 42, now we know that in triangle POR, PO is equal to RO, radii of the same circle. So if this is x, this is also x. So this becomes 180 minus 2x, angle POR. Similarly, if I take this as y and this as y, then QOS becomes 180 minus 2y. So I get this value and this value, and the middle one is 42. If I do sum of angles on a straight line, I get 180 minus 2x plus 42 plus 180 minus 2y is equal to 180. And then after solving, I will get some equation of x and y. X plus y is something. Let's say 111 or something. or maybe 21. Then in triangle PQT, x plus y plus this angle is equal to 180, out of which x plus y value we already know. So we can substitute it and get the value of t. But I have a simpler method than that. My method involves a construction, QR. Just join it. Because they have mentioned PQ to be a diameter. That was very important that they mentioned it. Otherwise, we cannot just assume that is a diameter. So O is the center here. So I know that PRQ will be 90 degrees. Similarly, QRT will also be 90 degrees, linear pair. Also, if the central angle is 42, then angle SQR will be half of that, 21 degrees. So in triangle QRT, if I know angle R and if I know angle Q, I can easily find angle T by angle sum property. Notice that I prefer using 3 letters for angles, but only if I've specified the triangle under consideration can I use a single letter temporarily. But in the end, the final answer should always have 3 letters to avoid any confusion. Also, whatever constructions you do, you should mention that. So that's a much simpler method, isn't it, compared to the XY method? Or did you find the XY method easier? Then try it on your own. Let's see if you get your steps correct. Next, the 53rd sum. Notice how even your homework sums, I have tried to solve it orally in the book. And that's how you should always start. First solve it orally in the book itself, and then start making statements out of it. In fact, if this diagram is too small, you should draw a huge diagram like I do. Look at this. Oh, huge. This was very difficult to draw. It requires artistry. Let's see if you are able to draw an accurate diagram. Yep, this is sum number 53. It's a lovely sum. So in this sum, first of all, angle AOB has been asked. They've given angle APB as 75, so angle AOB will be double of that, so that's 150 degrees. Next, angle ACB has to be found, Roman number 2. Well, angle AOB and angle ACB are supplementary because they are opposite angles of a cyclic quadrilateral AOBC. Can you visualize that? No? Get your eyesight checked. So if this is 150, this will be 30 degrees. Next, angle ABD. How do I find that? I have to join AB for that. So it's better if you draw a big diagram and write the values we've found till now, 150, and there was a 40 out here. It's already given in the question. This is 30. If you notice, ABDC is also a cyclic quadrilateral. So angle ABD and angle ACD are also supplementary. So if this is totally 70, this will be 110. And finally, Roman number 4, they want us to find angle ADB, this one. How do we find that? Various options are coming in my mind, like angle sum property. I'm looking for the easiest way out. How about this? Angle ADB is equal to angle ACB because they are cutting the same arc AB, angles in the same segment. So if this is 30, even this is 30. And look at the steps now. These are the steps. It's such a small sum. The sum is very small when you solve it, but the thinking process is time consuming. You have to do trial and error. But exam time, how would you know which angle to use, which property to use? Well, that's why practicing a lot of sums is important. That's why when you do the solved examples, you should not just copy and do it on your own and see if you are getting it. Train your brain. Next, let's go for sum number 54. It seems quite straightforward. 3 angles are given. We have to find BCD first of all. BCD, well, it's a cyclic quadrilateral, so 65, opposite to 65, so it will be supplementary, that comes up to be 115. Okay. Now ACB, this angle. How do I find that? Angle sum property? No, I don't have this angle or even this angle. I do see that ACB is equal to ADB. Did you notice it? Not yet. Come on, you should start noticing these angles in the same segment. But I don't even have ADB. That's okay. In triangle ADB, I have two angles, so I can find the third angle using angle sum property, and then this value, which comes up to be 45 degrees, is equal to this one, 45 degrees, angles in the same segment. Now show AC is a diameter. Well, angle ADC is 45 plus 45, 90. So whenever a chord subtends a 90 degree angle at the circumference, it is definitely a diameter. And that's the explanation you will give. So write all the statements. Next, 56th sum. Here, angle ABP has been given as 42 degrees. This one, 42 degrees. And we have to find angle PQB. That is this one. So how do we go about that? There are a few ways, a few methods. First of all, construct PO. Now if this is 42, then this will also be 42, because it's an isosceles triangle, isn't it? Radii, radii. By angle sum property, you can get angle POB. Once you get POB, then half of that is PQB, because angle at the circumference is always half of central angle. So that's one method. I have solved using another method. 42 degrees, so angle POA will be 84 degrees, because it's a central angle for this one. Linear pair, so I'm getting this as 96 degrees, and then half of this, so this will be 48 degrees. Roman number 2, they have asked this whole angle plus this whole angle. That's such a silly question. If this is 48, then obviously this plus this will be 180 minus 48, because it's an angle sum property, which comes out to be 132 degrees. So these are the steps. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.